Alright, this is an example of integration by parts. So we want to integrate this function here, and we have a combination of two functions that's not easily solvable using u substitution. So we have our formula for integration by parts right here, and the first thing we needed to do is decide which one of these is u and which one of these is dv. So I like to make a chart off to the side, u and dv. And then u, we're going to differentiate to get du, and we want that to be simpler, so we pick x, because that'll get simpler when we take the derivative. Du will just be dx, or 1 dx. And dv is something we're going to integrate, so we want it to not get more complicated when we integrate. And e to the x fits that bill perfectly, because when we integrate it, we're just going to get e to the x again. We have v is equal to e to the x again. And then we just apply our formula, so it's equal to uv, and we have them written down there, right there. So u is x and v is e to the x, minus the integral of v du. So v is e to the x, du is just dx, and now this integral is something we can solve. So this is equal to x e to the x minus the integral of e to the x dx, which is just e to the x. And we had an improper integral, so we have to add our constant. And we have our answer right there. And that was a really quick, short example of integration by parts.